Welcome to the Explainer. Today, we're going to do something really practical. We're taking a service that just works, and we're going to turn it into something that's actually production-ready and resilient. We'll walk through the 5 key stages using a real-world example, a Pi-hole instance running in Kubernetes. Okay, so here's our game plan. We're going to walk through 5 stages that I think you'll find pretty familiar if you've ever built anything for real. We start with the basics, then we harden it, we rethink the architecture, we automate everything we can, and finally, we add that professional polish that really makes a difference. All right, first things first, the foundation. So picture this. You've got your service, in our case, it's a Pi-hole DNS server, running beautifully inside Kubernetes. The problem? It's stuck in there. No one on the outside on your local network can actually use it. So that's job number 1.
So what's the deal? Well, the default service type in Kubernetes, cluster IP, is exactly what it sounds like. It's only reachable inside the cluster. Any client on your LAN trying to send a lookup, it's just going to time out. The fix, and you're going to love this, is surprisingly simple. It's just one kubectl patch command to switch it to a load balancer service, and boom, it's live on the host's IP.
Okay, now this slide is super important. You might look at that single command and think, what's the big deal? But we're classifying this as high risk. Why? Because you are directly changing the network perimeter of your cluster. This is a huge takeaway for operational maturity. The simpler the command, sometimes the more you need to respect its blast radius.
So our service is on the network. Great. But now we have a new problem, a big one. An open admin interface is basically a welcome mat for trouble. So step 2 is all about hardening. We have to lock down that web UI, and that means getting proper HTTPS set up.
You know, the easy thing to do here would be to just manually create a certificate and call it a day. But that creates a very human problem. Relying on someone's calendar reminder to renew a certificate, that's not a strategy. That's a time bomb. It's not a question of if it gets forgotten, it's when. So the real goal here has to be automating this whole life cycle. And this is how you solve it for real. We've totally replaced that fragile manual task with a dead simple script that runs on a schedule. It handles the whole shebang, generating a new key, getting it signed by our own local CA, and then pushing that new secret right into Kubernetes. It's true set it and forget it infrastructure. Love it. Okay, so we've done all this work. Our UI is now being served over HTTPS with a shiny, trusted certificate. But then, you still see that dreaded, not secure warning in the browser sometimes. What gives? This is a question that trips up so many people. And the answer, 9 times out of 10, is mixed content. The certificate is fine. The problem is what the page is loading. If your secure HTTPS page tries to pull in just one little thing, a script, an image, anything, over an insecure HTTP link, the browser is going to sound the alarm. It's a classic gotcha, and it means you have to go on a treasure hunt to make sure every single asset is served securely. All right, so our service is on the network, and it's secure. Now we get to the really interesting part, making it resilient. Let's dig into the architecture. We're moving past does it work and into can it survive a failure without anyone even noticing? So this is what we started with. Super straightforward, right? A client on the LAN asks our Pi-hole for something. The Pi-hole then just forwards that request out to a public DNS resolver on the internet, like Cloudflare or Quad9. And that works, for sure. But it creates a pretty big dependency on our internet connection and on those external services for all DNS lookups. Now look at the after state. This is so much better. We've brought the resolution process in-house by adding Unbound, a full-blown recursive DNS resolver right inside our own cluster. Now, Pi-hole talks to Unbound first. This gives us way more control, better performance for cached lookups, and, this is the clever part, we've kept the public resolvers, but now they're just a fallback. It's a safety net. But here's the thing. Having a safety net is useless if you don't know it's going to catch you. You can't just hope it works. You have to test it. So we ran a controlled failover test. A little bit of chaos engineering. We literally killed the Unbound service, scaling its deployment down to 0 replicas. And then we watched. And guess what? DNS lookups from our clients didn't even blink. They just seamlessly failed over to the public resolvers. That's how you prove resilience. Okay, at this point, our system is functional, it's secure, and it's resilient. It's tempting to just walk away, right? Job done. But no. The next level of maturity is automating supervision so the system tells us when something is wrong, hopefully long before a user ever notices. This is all about shifting from a reactive, oh no, it's broken mindset to a proactive one. And this didn't happen all at once. It was an evolution. You can see it here. It started with just a basic script, dumping health checks into a local log file. Okay, that's a start. Then we leveled up to webhook alerts. Better. Then we added more channels, email, Slack, Discord, so the right people get notified. And the final and maybe most important step, we added automated canary tests. It's a test that tests the alerting system itself to make sure it's actually working. A check for your checks. All right, we're in the home stretch. This is what I call the polish. This whole stage is about those non-functional requirements that really separate a hobby project from a professionally managed service. It's all about making the system maintainable, repeatable, and safe for anyone to operate for years to come. And the first step is so simple but so vital, just getting organized. Look at the before state. Scripts, config files, docs, they're all over the place. I call this path sprawl, and it's a huge operational risk. You could easily run an old script by mistake. The after state? Everything is consolidated into one logical directory. That alone eliminates a whole class of dumb mistakes. But just having your files in a neat little folder isn't the whole story. You have to manage how those files change over time. And that brings us to what is probably the single most critical housekeeping task for any dev or sysadmin, putting everything under version control. Using Git isn't optional. Without it, you are flying completely blind. You know, a huge part of using Git like a pro is knowing what not to check in. A well-thought-out .gitignore file is absolutely non-negotiable. You can see here we're telling Git to ignore the logs directory. We don't want all that noisy runtime chatter in our history. But look at the second one, ignoring the .k3s server directory. This is critical. This is how we prevent sensitive, machine-specific configs, and most importantly, secrets from ever being committed to the repository. Huge. And that's it. That's the whole journey. We literally started with a single kubectl command just to get a service talking to the network. And from that one little step, we methodically layered on security, we built in real architectural resilience, we automated our monitoring, and we applied the professional polish of solid configuration management. So this whole journey really leaves us with one final thought. Look, getting a service up and running, that's table stakes. Making it truly managed, that's a whole different ballgame. So the question I want to leave you with is for your own projects. Your service is running, but is it managed? What is your very next step on that journey toward operational maturity?